server, it will tell you which server you should be subscribing to receive the publish commands.
Okay, the complexity of PubSub is proportional to the number of clients subscribed to a given channel. So you just set up a master, alt publish to the master, and the other clients can subscribe to a random server, a random slave. It's already a cluster.
If it tries to subscribe to the wrong master though,
no, there is no wrong, no, you should subscribe to slaves. There is no wrong slaves, because every publish will be broadcasted to all the slaves.
But if slaves in the cluster will receive, all slaves in the cluster will receive the publish.
Exactly, because the publish is very cheap to receive. If you don't have clients attached, basically it will be discarded completely. Because we do an hash table lookup, there are no clients for this pattern, and we just discard. So we have already a PubSub cluster in some way.
Thank you.
Thank you.
At the back, in front of
Yeah, what about commands that operate on multiple keys, like set intersection, for example?
Okay, this will be supported only in a limited fashion, that is via hash slots. This means that if you have something like this, foo var, the hashing algorithm is run only in this part. Okay? So you should make sure to have the same hashtag in every key you want to intersect, because the cluster will, when it's in cluster mode, the node will reply without problems if all the keys in the multi-key command will hash to the same hash slot. If instead they will hash, at least one will hash in another slot, there is an error returned.
So make sure they're in the same hash slot.
Yeah, because the only way to do this in a way that's transparent for users is to do migration of keys, temporary migrations, intersections, then again deleting the value. So basically, even if we can give the illusion of supporting this will be slow, and it's really something to get right at application level.
From your slides, it looked like the hash slot algorithm is derived from CRC16. How would you go about actually ensuring the two keys were in the same hash slot?
Sorry, I didn't understand.
I mean, if you wanted to ensure that a group of keys were within the same hash slot, so you could run, say, intersections on them, how would you ensure that the hashing algorithm puts them in the same hash slot?
With this, the tag.
Okay, right.
So you have two keys. You have A user 0 and B user 0. You are sure this will hash the same, because just the part between brackets is hashed.
Because the hash slots aren't computed against a key, they're computed against a tag.
It's just a trick. You use as the key name this format.
Okay.
And the Redis cluster is guaranteed to understand this format.
Okay.
This, of course, is a limited solution. Works in some kind of applications, but in some other applications, you want to intersect things with things that are of general interest to all the nodes, and this can scale. It's the kind of thing you should try to do application level, or better, even better, try to find ways to avoid it at all, because it will be slow anyway.
Any more questions? The back.
My question is actually about Redis 2.2 and the hybrid data types that you talked about, especially for the lists where you actually switch the underlying structure to save memory footprint. What's the actual impact of that? Like at runtime, is there a CPU spike of some sort, or
yeah?
I'm just trying to think like how likely is it that the whole list can be saved in the CPU cache and that it happens really quickly, really transparently, or will the clients actually experience delays?
Well, it all depends on your thresholds, of course. If you set your threshold that a zip list of a million elements should be converted to a list, yeah, you're likely to be noticing a couple of milliseconds delay before you get the response back, where also the server will be blocking. However, if you choose your thresholds like the defaults that I mentioned, something like 1,000 elements, it's all very fast. So, and it only happens once per key. It's not when it goes under the threshold, it's converted back. It stays in the linked list. It's when you start pushing to a list, it's a zip list. Once it goes over the threshold, it's converted to a linked list, but it's never converted back.
Okay.
So it's when you have a good vision about your own data, you know what the average list size is, what your typical use case is. You can greatly use these kinds of tricks to make your memory footprint a lot smaller.
Okay.
But in short, no.
Yeah. Okay.
Okay. Anyone else got a question? Yeah, go ahead.
But ask, with the insets,
Yeah.
where the complexity has changed, what for is member and push and pop things, what about the more complex operations like set intersections and set unions?
Well, because that's a good question actually. That was also discussed on the mailing list a couple of weeks or a month back. I can't really remember, because I calculated in my head the changed complexity of these comments, but it was questioned at a later time. We can apply a trick here, namely that because the insets are ordered, once you go over a certain limit, you don't have to review that limit in all the other sets as well, right? If you do an intersection. Because if you know that like set 1 starts at the first set of your intersection list starts with a number 5,000, and the rest of your sets start at 2,000, you know you can discard all those sets up to 5,000. So you search, basically do the you take advantage of the fact that the sets are ordered, something you don't have with the dictionaries, of course.
So there's a chance that the complexity of intersections will actually drop a fair bit.
Well, yeah, but then again, that's not really what complexity is about. It's about also worst case, of course. And worst case, it's
Or the end,
okay.
the worst, I think.
I'm getting confused now.
It's just
Can't
all
really-
the end,
really
because,
work.
okay.
Yeah,
You have this-
n times n.
Okay, this is min and max of 3 sets. You already know, just looking at the picture, that you can select the max min and the min max. So you know already it's here. And you have to run the intersection just between this and this. So in the worst case, the sets have the same min max. And this is going to be ODN per m. But m, let's consider m fixed and small, that you intersect with a few sets, so it's ODN, more or less.
Yeah.
But
Good,
again, here we are talking about small sets. If it's big, there is the hash table.
But thanks for the question, because I'm going to be looking at that later on, because I think it still needs some attention for
So-
2.2.
Yeah, yeah.
for the RC. Yeah.
Well, it's a shame that there is the conversion stage, because insets are performing so well that we can use them for larger sets just because of the latency introduced by the conversion. Otherwise, they can scale up to a lot of elements. But there is the conversion time that is going to kill big insets. Of course, it's up to you, because it's something you can configure. So you have to understand your latency concerns, your memory footprint concerns, and so forth.
And we don't say that this is where we stop. There's also always the possibility of having a linked list of zip lists, or a dictionary storing int sets, or but this is all very, very complex matter, of course, and this is just the first step at it, and it will work in, I don't know, maybe 95% of all the cases. But when the need arises for such things, we will definitely be thinking about it, of course.
Okay, I think Peter's here. So last question. Go ahead.
Was the question that asked earlier on about hashing bars in specific hash slot?
Yeah.
So let's say that bars hashes down to slot 7. Now, the biggest machine I have has got 72 gigabytes of RAM. Now, when it goes to this hash slot 7, all the data for bar is more than the 72 gigabytes. I find the current hash-based mechanism kind of limits you. Am I wrong in understanding that it limits you to basically
The hashtags?
the what?
You mean the hashtags?
Yeah, the hashtags. Yeah.
Well, you are not writing here 7.
Sure.
So I expect this to be distributed as well. User 0, user 1, user 2. So it should distribute to all the nodes.
Sure, but let's
Of
say
course, if you use always the same hashtags, you are turning the cluster into a single instance. Yeah.
No, but I'm not saying that I'm trying to target that particular instance. It's just, let's say there's a huge amount of data for that specific tag. Let's say that all of a sudden Britney Spears gets really popular once again, and so all of that data goes
There is to use this with care. If you know that your hashtag is not going to be distributed evenly or, well, more or less evenly, because you have always the hash slots that can save you, because you at a given point can have the seed to take just a few hash slots in a given instance and many more in the others. You have a way to distribute in an uneven way the hash slots using Redis Ether.
Right, but okay, so if I might actually just build up to the actual question I wanted to ask was, if we instead, for example, leverage this into having lexicographical sorting. So for example, so we can do kind of multi-exec, kind of doing range queries, etc. Because I mean, it seems the underlying infrastructure could allow for that just as well. So you don't actually need it to be based on just a hash-based mechanism. Does that make sense? So I can say, find everything between the price of £20 and £30, and so all the keys and everything, it's all kind of sorted lexicographically. So all the clusters, they kind of dynamically allocate themselves. So even if one particular cluster grows beyond, say, the size of a specific server can handle, it can be partitioned quite dynamically. Whereas with a hash-based mechanism, you're kind of limited beforehand. You can't kind of partition.
Okay, you say the number of partitions you have.
Yeah.
Okay. The problem is that there is a trade-off. If you make these partitions too much, the configuration is too big to be sent in the ping-pong process, to be saved, and to be communicated in the client hits. So why it was selected this specific number? Because anyway, I think this kind of model is not going to scale over 1,000 of nodes.
Sure.
And again, we are a bit to the limits, but what they did was to make this as a defined inside the source code. So you brave users, it will multiply, can recombine values, setting this value to a much bigger one, and write larger instances. But I think that if this will work well for the usual clusters people will run, 200, 300 nodes, this is already a huge win, and we will figure out how to make it working with larger clusters, or how to have a better granularity.
But what I'm saying is,
Okay. So thanks very much. Thanks to our sponsors.